Hi, this is Professor Tiffany Martin with Medical Microbiology. We are in chapter 1 and we are working our way through. Okay, so Louis Pasteur is living at this period of time, and let me just ask you a question. Has anybody heard of Louis Pasteur? Of course you have, because Pasteur is short for pasteurization. This is a process he developed that we use today, still today, to preserve our milk and our juice and other things are pasteurized. I bet you have not heard of Spallanzani or Needham or Reddy. The reason we have heard of Pasteur is because his experiments at this time period held up, and it still holds up today. So Pasteur is a scientist living in this time period. He knew about Reddy and his experiments. He knew about Spallanzani. He heard about the critics. Pasteur did not believe spontaneous generation was possible. He said that living things have to come from other living things. So he set about designing a good experiment that critics could not question from that. All right, so let's see what Louis Pasteur did. Louis Pasteur did the same thing as Spallanzani. He took a glass container, he added plant matter and materials, and he boiled it. He boiled it a very long time. But what he did is he wanted to be able to make sure that air could come in and out of these containers. So he created this new shape to these containers, to these flasks, and this is now known as the swan neck flask. You can see how it bends here. Now this does two things. You can boil it in the glass container because steam can escape. The other thing is we know that if steam can escape, air can move in. So air can freely move in and out of this. So for the critics saying that air is necessary for spontaneous generation and you need some sort of life force in the air, this allows the air to move in and out. All right, so Pasteur, he boiled his plant material, he kept it in the flask, allowed it to cool, and then he allowed it to sit. And he watched it, made observations 1 day, 2 days, 3 days. The entire time, there is no growth. There is no cloudiness. There are no microorganisms. He repeated this experiment over and over again. He allowed these to sit up until 18 months. He actually had like this under the staircase cabinet, and he kept all of these things in this area under the stairs, and they would sit on the shelf for months. He would come back to them, make observations, and the entire time this liquid did not get cloudy, did not decay, did not smell. It remained without microorganisms contamination. What he did notice was that dust began to gather. So as air is coming in and out, dust would also come, collect here, and stay there. So one day he got the idea to see what happens with this dust and what would happen if this dust came in contact with the liquid. So he tipped his flask, allowed the liquid to come in contact with this dust that was collected here, set it back upright, allowed it to sit. After 1 day, 2 days, he got a cloudy liquid. Microorganisms appeared. His conclusions: spontaneous generation does not exist. Microorganisms come from other microorganisms from this. Air can come in and out as long as the dust and what we know now, the microorganisms within the dust, do not come in contact with the liquid stays sterile. Now this was pretty exciting. This was a solid, well thought out experiment. It answered all the critics' questions about this, and from this moment on, people became convinced spontaneous generation does not exist. And in fact, Louis Pasteur made a famous quote that he says, "Never will spontaneous generation recover from the mortal blow of the simple experiment." I think this is kind of funny. It just kind of shows that what happens when you design a good experiment, when you answer all the questions and design that experiment, then it stands, then your data stands. And so this is another reason why Pasteur's experiment still, this particular one, remains valid today. We have not gotten any new data that has contradicted what he did. And that, again, was the design of a good experiment. So let's talk about Pasteur. He did this, the scientific method. Again, you've been learning about this for forever. We naturally do this. We're curious people. We naturally make observations. We naturally question things. When we don't know the answer, we come up with one. This is kind of a hypothesis. And then if we are smart, we will test that hypothesis. We will move into the experimental phase and actually make sure that what we believe is the answer to our question is actually, in fact, the answer. So we will do an experiment, record some observations, and then we've got two outcomes. Either the experiments support the hypothesis, so we accept it, very good. We can repeat it to make sure, or the experimental data does not support the hypothesis. In that case, we can reject it and move on, but we're curious, so we are going to actually kind of modify, well, if this wasn't true, because of what I did here and what I observed, what could be true? Let's modify this hypothesis and then try again. And that's usually what we do. And again, we do this all the time. We are constantly filling in the blanks, coming up with this. The smart thing is to keep those opinions, the hypothesis, what we think is the answer to the question, and then move forward into experiments. So keep that in mind as we're going through that. All right, so Pasteur is well known for starting this very scientific way of making observations, questions, hypothesis, experiments, observations, and conclusions from there. Okay, so Pasteur was very well known, and there was some problems going on in the wine industry. Remember, one of the questions that they were concerned about was what causes fermentation. Again, we've been making wine, making bread, making beer for centuries, but sometimes it didn't work. And the French wine industry, which is famous for their grapes, was having a problem. Many of their batches of wine were spoiling. Instead of being alcoholic, they were acidic and bitter. They couldn't be sold. Now, this was a big deal, and they couldn't figure out what was going on. And so they contacted Pasteur and asked him to come help them. So Pasteur came out to apply his scientific method and the things that he had learned to the problems in the French wine industry to see if he could figure out what was going on. So, all right, so let's see what is going on in France. So what did he do? First thing he did, make his observations. He looked at grape juice and looked at fermenting grape juice and took some samples and looked at it under the microscope, and he found these microorganisms. These microorganisms, lots of different types of microorganisms were present in this fermenting grape juice. His question: could these microorganisms be involved in making wine? Could these microorganisms be involved in spoiling the wine, causing it to turn acidic and bitter? So his first question is, okay, so how do these microorganisms get there? What's going on? His first hypothesis is when we put grape juice in a container, these microorganisms spontaneously ferment. So we have microorganisms in there, and we can have spontaneous fermentation. Just if the grape juice, so even without the microorganisms, let me start back, sorry. Even without the microorganisms, if we just take the grape juice, we get rid of all the microorganisms, then grape juice spontaneously turns into wine over time. So his hypothesis is spontaneous fermentation occurs. He takes the grape juice, he boils it, so he gets rid of everything, and he actually seals it with this. So he seals the flask. He looks to determine if this grape juice will spontaneously ferment into wine. His observation: no fermentation. It stays grape juice. There are no microorganisms, and there only remains grape juice. So spontaneous fermentation just with grape juice alone does not occur. So if it's not the grape juice that leads to fermentation, and maybe it's the air plus the grape juice. Remember, he sealed this one. So his next hypothesis is the grape juice in combination with air will undergo fermentation. He boils the sample. He's using his Ch1 flask, so we know air can come in and out. He allows it to sit, observes it over some days, and he's looking to see if grape juice will, in the presence of air, will spontaneously turn into wine. Observations: no fermentation. The juice remains. We still don't have any microorganisms, which we know that because we boiled them, but grape juice plus air is not going to get us wine. So it's not the air that's causing fermentation. So now he's thinking maybe these microorganisms are involved, but which one? There was lots of different types. So his first hypothesis was maybe there are some bacteria that are present in the grape juice that will allow the fermentation of the grape juice into alcohol. So he gets rid of all of the microorganisms, and then he adds back just the one he's questioning. Is bacteria responsible? So he boils everything, and then he adds back the bacteria. He goes ahead and seals it because we know air is not going to cause it. So he went ahead and sealed it. So we have bacteria plus grape juice, and then he made some observations. What happened over a period of time was the grape juice turned into acid. It became bitter. This was the contamination that the French winemakers are trying to prevent. Acids do not cause bacteria. Making acids do not cause alcohol. They end up with acids. So the bacteria is not responsible for fermentation of wine. Bacteria are actually responsible for fermentation, making acidic end products. And this is why we get that bitter wine. All right, so now he's learned something. He still hasn't answered his question, what causes grape juice to ferment into wine, but we do know what causes it to spoil. So even when you get a negative result from an experiment, you get some useful information. So his bacteria is what's causing it to spoil. All right, so let's go back to here. What other microorganisms are available? One other microorganism he observed was yeast. So this hypothesis, he says, well, maybe it's the yeast that ferment grape juice into alcohol. So gets rid of everything, boils it, and then adds back just the one variable that he's testing. He adds in the yeast. So we have grape juice plus yeast. This time, his observations over a period of time, the yeast produce alcohol. So now we have our answer. Yeast plus grape juice will ferment into alcohol. So how do we make sure we get alcohol? We need to make sure there's yeast. How do we prevent it from spoiling and turning into acid? We need to prevent bacteria from growing. So this was huge. This experiment gave the French wine industry the necessary knowledge they had so that they could produce wines over and over again and prevent contamination from bacteria leading to acids. So this was huge. And it really saved the French wine industry. So he took this discovery of how fermentation works, the knowledge that yeast plus grape juice equals wine, bacteria with grape juice equals acids. He took this knowledge of how fermentation occurs. He says, how can I make this do what I want it to do? So he developed a process called pasteurization. This is where you take heat, you get rid of the microorganisms, and then you allow it to cool, and this prevents spoilage of the milk, and you can allow that to go for a longer period of time. And we still use versions of this today for pasteurization. All right, so with this knowledge, he was, oh my goodness, he was able to figure out the process, discovered how fermentation worked, and then he was able to develop a new method, a new process that reduced this contamination that we call pasteurization. Now, this was the first time we took some science here with microbiology and we applied it in a practical consideration. This led to us using science, microbiology, into lots of different fields. This started the field of industrial microbiology, using this dairy and other foods, this process of pasteurization and reducing or getting rid of contamination and bacteria. We use this in wastewater treatment plants. We use this to produce medications and insulin for that. Biotechnology, biochemistry, all of these practical applications that we get today are because Pasteur designed a good experiment. He was able to use that to come up with the answer to how fermentation occurs and then develop a procedure or a process to make sure that we got the outcome that we wanted. So Pasteur, we will remember him. He did a great job, and this is what we're going for there. Okay, so we will stop this video right here and pick it up with Pasteur's additional contributions and what that meant to some other questions we had in the golden era of microbiology. Thanks for watching.